Okay, so I just realized that I finished this this problem, which was part A, and I never went to part B. I mean, I talked about part B, but I didn't really show this slide. But this basically says that by adding Dahlia and increasing the size of the legislature according to the number of reps that it deserved, B had to give one of its reps to A, and this illustrates the new states paradox. Okay, so anyway, moving on. Okay, so now we're gonna, enough with the paradoxes, we're gonna actually talk about those other apportionments that I referred to about Jefferson, Adams, and Webster. But they're going to use the standard divisor and the standard quota. However, they do it a little differently because sometimes things don't add up. So what they're going to do is modify the quota. That's the part I said, oh, I got to talk about that later. And here we are. Okay. They will literally use trial and error to find a modified divisor that is smaller than the standard divisor for the apportionment. Now this is using Jefferson's method, and I need a bigger, wider highlighter. There we go. Jefferson's apportionment method. He's going to use trial and error to find a modified divisor that is smaller than the standard divisor for the apportionment. And he'll calculate the modified quota, which is the state's population divided by the modified divisor for each state, and round down. I'm going to put that in a different color. He will round down, and then he'll assign the number of reps to each state. You'll have to keep varying. This is where the trial and error comes in, the modified divisor, until the sum of the assignments adds up to what was being apportioned. So if it only adds up to 8, you're going to have to fix that. Now, I need to talk to you about math for just a second. Basic math. Okay, I think I can show this on this slide. I'm going to use the number 12. Okay, if you take 12 and divide it by 2, the answer is 6. If you take 12 and divide it by 3, the answer is 4. If you take 12 and divide it by 4, the answer is 3. If you take 12 and divide it by 6, the answer is 2. Okay, when you look at what I'm dividing by, first I divided by 2, then I divided by 3, then I divided by 4, then I divided by 6. As the number that I am dividing by gets bigger, what's happening to the answers? They're getting smaller. And if I were to flip that around and do it the opposite and say 12 divided by 6 equals 2, 12 divided by 4 equals 3, 12 divided by 3 equals 4, basic math, 12 divided by 2 equals 6. Now when I look at them, now the number I'm dividing by is getting smaller. I went from 6 to 4 to 3 to 2. As I do that, my answer ends up getting bigger. Okay, keep that in mind. I may have to come back to this slide. All right, so let's look at these same 3 companies, Naxon, Erico, and Eurobile. And before we used the Hamilton's method, but now we want to use Jefferson's method. We're going to use Jefferson's method to apportion the board. So we have to start by, adding them all up. There's the 10,000. Hang on, what was it? It was a 9-member board. And we've got all these stockholders here. right? And this added up to 10,000. So your standard divisor, our standard divisor, you're going to take the total population and divide it by the number of seats that are going to be apportioned. And I'm guessing my math lab said take it out 2 places. So there's the 1,111.11. Okay. In Jefferson's method, we want to find modified quotas so that when we round these quotas down, the total is 9. This means that the modified quotas must be larger than the standard quotas in order to get larger modified quotas. We must have a modified divisor that is smaller than the 1,111.11. Now I think what they show you on the next slide is, and here's one of these annoying things that bothers me. It's like did 2 people put together these PowerPoints? Because normally they would put, Naxon, Erico, and Eurobile, like this, like vertically, and now they're putting them horizontally. It's like, come on, people, be consistent, would ya? I don't know, maybe they're just messing with you. But anyway, I can see there's the 4,700, there's the 3,700, there's the 1,600. And they already did the modified divisor, which was the 1111.11. And where the heck was that? They did that originally. Was it way back here? No, where was it? Back in the beginning. No. I know we did it earlier because I remember that number. Where was that number? Oh, there it is. There it is. We did it here, and they were using Hamilton's method. So Hamilton would have used 4 and 3 and 1. 4, 3, and 1 only adds up to 8, right? There's not all the 9 there. So it's the same thing. You can see for Jefferson, he always rounds down. And he would go with 4 and 3 and 1, which adds up to 8. That's too low. He needs it to add up to 9, okay? Which means at least one of these numbers has to get bigger. Remember, these numbers here, you're going to get those after you divide. If you need one of these numbers to get bigger, then what you're dividing by has to get smaller. Remember, where's that slide that I did it on? Right here. There it is. If you want your answers here to get bigger, then what you're dividing by has to get smaller. So, where's that slide? Right here. So it says Jefferson, I'm going to go with pink again. Jefferson's method with the modified divisor of 1,050. Now you might be asking yourself, April, why 1,050? Why not 1,100? I don't know. Just pick a number. Now here's the problem. Sometimes you pick a number smaller and you go too low, and then that doesn't work. So you got to come back up again. And then sometimes you go too high, and then you got to go back down again. It could be a vicious nightmare here. So, and I'm looking at my little clock, and I'm about to run out of time. So, because this program only allows me to talk for 10 minutes free. After that, I have to pay for it, and I ain't got time for that. So, I will finish this video in another, or this example in another video.